Hello and welcome to Geometry, Law of Sines, and Area Using Sine. In this video, we are going to solve problems using the Law of Sines. When given two sides of a triangle and a non-included angle, we are going to determine if there is one solution, no solution, or two solutions. And then we're also going to find any missing angles or side lengths if there is one or two solutions. And then we're also going to touch on finding the area of a triangle when given two sides and the included angle. Here are some of the standards that we are going to touch in this video. These are from the Florida's Best Standards for Mathematics. So let's start off with what is the law of sines. So we've already in our previous video talked about trig ratios, but we can also use the law of sines as we've been talking about how sides are proportionate to their opposite angles. And so the sine of A, which is the sine of the angle, over its opposite side is going to be equal to the sine of the other angles across from their opposite sides. And so let's go ahead and take a look as to what that's going to look like when we write it out. So see how 30 degrees is across from 24, and then we've got 47 across from x. So we are going to use that to build our proportion. And so we've got the sine of 30 degrees over its opposite side, which is 24, is going to be equal to the sine of 47 across from its opposite side, which is going to be x. And so from here, we are going to cross multiply. So we're going to have x times the sine of 30 equals 24 times the sine of 47. And then from here, instead of typing all of this into the calculator right now, we're going to wait until the very end. So to get x by itself, we're just going to divide both sides by sine 30. And so now I have x is equal to 24 sine 47 over sine 30. And then we're going to type that into our calculator. So remember that using our calculators that we are using on our EOC can be a little bit tricky for trig functions. So you might feel more comfortable using the on-screen Desmos calculator that's available to you while you take your EOC. But if you feel comfortable using your handheld, that's good too. All right, so with our handheld, we're going to clear it out. We've got 24 times, and then don't forget that that angle is going to be written first before the sine function. So we're going to say times 47 and then hit your sine button. And then if you feel better, go ahead and hit equals. Then we're going to divide that by 30 and then hit the sine function. And then don't forget to hit equals at the end. And that means that x is going to be 35.1. And now that we found out what x was, we could go ahead and figure out this third length as well. So if you wanted to, we know that this is 30 and this is 47. And that would make our angle here 103. And then we could label this as y and figure out what y is by setting up another proportion. And so you can see how the law of sines can help us figure out missing side measures when we can't exactly use something like the Pythagorean theorem because they're not right triangles. All right, let's go ahead and try this other one. So we're going to do the same thing with this one. I see that 51 is across from x. And then see how we have 32, but we don't have that third measure. And so we have to use our triangle sum theorem. So we're going to do 180 minus 51 minus 73, and that gives us 56. And now we have that 56 going across the 32, and now I have what I need to create that proportion that I need. All right, and so now we've got the sine of 56 over 32 is equal to the sine of 51 over x. And then we're going to do that same thing that we did before. We're going to cross multiply. And now I have x times the sine of 56 equals 32 times the sine of 51. To get x by itself, I'm just going to divide by the sine of 56. And notice that it's just like when I'm doing my regular math, when I'm dividing by that same thing, it cancels out. And so now I can put this all into my calculator. So now I have x is equal to 32 times the sine of 51 over the sine of 56. So I'm going to grab out my calculator and I make sure I clear it. And so remember with these, you have to type that angle measure first. So we have 32 times 51, and then you hit your sine function. Hit equals if that makes you feel better. Divided by 56 sine. Make sure you hit that equals at the end, and I get 29.99. So if I'm rounding to the nearest tenth, that's just going to be 30.0. Okay, and so that's how we use the law of sines. Now this is where some things get tricky. So we have this case of two triangles. We've been talking about triangle congruency and triangle similarity, and we know that side-side angle, whether it spells ass or ass backwards, it didn't work, right? And that was because we had the case of two different possible triangles. So looking at these shapes, notice that they have the same two side lengths, and then they have that same angle measure in the corner, but we have two different triangles here, and that's because this side here was able to kind of collapse and hinge downwards to create a different triangle because this angle wasn't being regulated. And so when we have two sides and a non-included angle, we could end up with two possible triangles. With the triangles we just had, they gave us two of the angle measures, and so they could only be one triangle because we could figure out that third one. So now let's kind of look at the law of sines in a different way. So now we're going to talk about whether we have no solution, one solution, or two solutions. We have those two different triangles. And so let's look at this triangle here. So when I go to do these triangles, I usually just draw out a triangle. It doesn't have to be any certain type. And I'm going to go ahead and label it A, B, and C. And so with measure of angle A being 125, and then A is 22. That means it's across from angle A, and so I'm going to put 22 here. And then B is going to be across from angle B, so that's going to be over here. And so now let's kind of think about our triangles with this one. So with this triangle, there's only going to be either no solution, it's not going to make a triangle at all, or it's going to be one solution because they gave us an obtuse triangle here. And so if I'm searching for angle B, right, and I'm putting this as X, it can't be another obtuse angle. When we looked at these other angles we were talking about, it was either acute or obtuse. And so if we were looking for one of those other ones, it could be one or the other. And so with this one, it's either going to be no solution or it's going to be just one solution. So let's go ahead and try to use our law of sines. So we've got x across from 15, and then we've got 25 across from 22. So we have the sine of 125 over 22 is equal to the sine of x. Don't forget you're using those degree measures with your sines, over 15. And then we're going to cross multiply. And so now I have 15 sine 125 equals 22 sine x. Now to start to get x by itself, I'm going to first get rid of that coefficient out in the front. So I'm going to divide both sides by 22. And so now I'm just going to come up here. I have 15 sine 125 over 22 equals the sine of x. And then remember back when we were doing our trig ratios, I know that multiplying by the inverse is going to get rid of that and just give me x. And so now I'm going to take the inverse sine of this piece right here. This is where using our calculator properly really comes into play, because we're going to lean on our calculator for these answers. Remember, you can still use your on-screen calculator during your EOC with Desmos. It's a lot more clear, and you definitely can tell whether you made a mistake with typing or not. With these handheld calculators, it's a lot harder because you can't see what you typed. All right, so we cleared out. We have 15 times 125 sine, and then if you want to press equals, divided by 22. That gives us what's inside the parentheses. Then you're going to hit second sine for that inverse, and we get 33.95. And so we're just going to round that to 34 degrees. And so angle B is going to be 34 degrees. And then that would make angle C, where we would just do 180 minus that 125 minus that 34 degrees, and we get 21. And then you would be able to solve for length C from there. And so I'm not going to show you that because it's that same process of building out our proportions and solving. And so for C we get 9.6. And so this is 21, and then this would become 9.6. And so our calculator was able to show us our answer. If we had no solution, our calculator would say error. All right, so let's go from there. So let's try another one. So with this one, I'm going to draw out my triangle, label it A, B, and C. For angle A, we've got 48 degrees. Side A, which is across from angle A, is 11, and then across from angle B is 16. Now with this one, notice that our non-included angle is acute. That means I don't know if B is going to be obtuse or not. And so I'm going to start building out my proportion. So I'm going to make BX, and that's going to be across from 16. Then we've got 48 across from 11. So I've got the sine of X over 16. is equal to the sine of 48 over 11, and then from here I'm going to cross multiply, so I get 11 times the sine of x equals 16 times the sine of 48. Remember, we want to get rid of that 11 first. And so now I have the sine of x is equal to 16 times the sine of 48 over 11. From here, you can guess that we're going to do the inverse sine on both sides to get rid of that sine in the front. And so we're going to end up with x equals the inverse sine of that fraction, so 16 sine 48 over 11. And so now we're going to put that into our calculator. So I'm going to make sure it's all cleared out. And remember, you start with what's inside the parentheses. So we've got 16 times 48 sine, press equals, divided by 11, equals, and then I'm going to do second sine, and it gives me the error. That means there's no solution. And so this is why it's super important that you type it into the calculator correctly, because if you don't type it into your calculator correctly, it can give you the error message. So that's why you definitely want to be careful and use that on-screen calculator if you need to. So this one is going to be no solution. Okay, all right, let's try one more of these. So let's build out our triangle. We're going to label it A, B, and C. Angle A is 30, and it's going to be across from 3, and then B is going to be across from 4, and then I'm going to put X here. All right, so we have X across from 4 and 30 across from 3. So we've got the sine of X equals the sine of 30, and then we're going to put those over their opposite sides, and then we're going to cross multiply. So I've got 3 sine X equals 4 sine 30, and then we've already kind of seen how this goes, right? And to take this, we're going to take the inverse sine. And so I'm just going to go ahead and skip ahead. It's that same process every single time. So these become a lot faster once you kind of see the pattern. Okay, all right, so let's type this into our calculator. Notice that we have an included angle that is acute, and so we don't know if X is going to be obtuse or not. So it's either going to be no solution or two different solutions. So now we're going to put this into our calculator. So I've got 4 times 30 sine equals divided by 3, and then I'm going to take second sine, which makes it the inverse, and I get 41.8. I'm just going to round that up to 42 degrees. And so for this one, X could be 42 degrees. And so when we're looking at X can be 42 degrees, or X can be 180 minus 42 degrees. And that's going to give us 138. So it could be either one of these. And so this is what they mean by those two solutions, because we've got those two triangles and we don't know whether B is that obtuse angle or not. And then from here, you're just going to solve out as if you had two different possible triangles to figure out what angle C, and what would be across from that would be. So for one possible triangle, we have a 30, 42, and 108 triangle, where this is A, B, and C. And then we've also have that second triangle where we have angle A, which is 30, and then angle B, which is 138. And then when we do 180 minus 138 minus 30, we get 12. And so these are the two different triangles that we could be looking at. So you can draw out those two triangles if that helps you out with building out your proportions to figure out what the lengths would be for C. And so with this first triangle, the length of C would be 5.7. And then for the second triangle, C would have a length of 1.2. And this goes back to this idea of having two triangles where you're either going to have this long length here, or you're going to have this shorter length. And so when you have the larger angle here, you're going to have that shorter length. If you have a smaller triangle, you're going to have that longer length. And that goes back to this one where we have that larger triangle where you're going to have that that shorter length there. All right, now let's switch gears and let's use sine to find area. And so this is when we have C is the included angle. And so this is a formula that you have for area. This is used for honors geometry, so it may not show up on your EOC, but we're still going to cover it in our lessons. So we have A, or the area, is equal to 1/2, and then you have your two side lengths. And this is where C is your included angle. So C has to be in between the two lengths. And so if they gave you maybe these two angles, maybe you have to solve for 140, just make sure that you're using your included angle on this one. Or if they gave you all three sides, make sure you're using the two sides that create that included angle. And so we've got area equals 1/2 times 6 times 5 times the sine of 140. And so this is all calculator work. And so 1/2, we can put that as 1 divided by 2, close parentheses, times 6 times 5, even though we know 6 times 5 is 30, and then 1/2 of 30 is 15. And then we've got times, and then make sure you put that 140 first, and then hit that sign button, and then make sure you hit equals at the end. And that's going to give us an area of 9.6. And then we want to put the units, and so that's going to be inches squared. And so you're just using a formula for this, easy peasy. And that concludes our video.